The composition of functions. You should be familiar with functions and function notation. In this lesson, we will define the composition of two functions. Recall that a function transforms an input to an output. For example, the function f squares the input to produce the output. It does not matter what variable is used for the input. The function f squares the input. The input may be a specific number, like -3. The function will square -3 to give the output of 9. Sometimes we use an entire function as the input. We could use the output of the g function, g of x, as the input to the f function. In essence, what we have done is split a complicated function into smaller steps. If g subtracts 3 and f squares, then the composition first subtracts 3, then squares. For example, if 7 goes into the g function, 4 will come out, which then gets squared in f to produce the answer 16. If we begin with 0 as the input to g, we get 9 as our final answer. In general, when an arbitrary input x goes into g, the output is x minus 3. The x minus 3 is then the input into f, which gets squared to produce the answer x minus 3 squared. Here is the previous example presented formally. Recall that the input variable to a function is merely a symbol to help identify where the input is located in the function. We could use a different variable, or just indicate it with a spot, or use a different color. The input to the function f is the output of the function g, which is x minus 3. So we replace the input to the f function with x minus 3. Does the order of the two functions matter? In general, the answer is yes. When we use x squared as the input to the g function, the x squared replaces the red dot, and we get a different answer, x squared minus 3. Here's another example. To find the first answer, use the output of the g function as the input to the f function. That is, plug 3x into the f function. The f function takes the square root of the input, which in this case is the g function, shown in red. So that we are taking the square root of the g function. To find the second answer, use the output of the f function, that is, use the square root of x, as the input to the g function. Again, the input function is shown in red, and in this case, the g function multiplies the input by 3. Here's another example. As in all examples, to find the composition of two functions, use the output of the inner function as the input of the outer function. We can compose as many functions as we like. F of g of h of x will be the function that multiplies by 3, then subtracts 6, then takes the square root. To recap, to compose two or more functions, use the output of the inner function as the input of the outer function.